Alright, today's lesson is on slope. Slope is the steepness of a line or a linear graph. Alright, so from previous work, we know that when graphed, a linear function or linear data, depending on where we're at, is going to be a straight line, as you can see here. Now, I didn't give those points at any point in time. At any time, I just wrote it down, so we can think that straight line equals linear. All right. Now maybe we think of the word slope. Where does that come from? Maybe I ski down those slopes, or there's a slope on, whatever skateboarding rack you're going on. I'm not sure. Last time I tried to skateboard, fell down and compressed my vertebra. Not a fan for me. But this actually exists in a lot of places in life. For those of you who are driving already and have driven over the Grapevine in Southern California, you'll notice that it has a 45-degree slope. That sign is to let truckers know that they're slowly declining in elevation, and their speed is really easy to pick up and they don't want to get left behind. Also, for you people who are already driving, don't be like one of my old coaches and continue with that speed and then get pulled over on the Grapevine. Bad idea. Alright, so to figure out what this is, to figure out what the exact steepness of this line is, first things first, I need to have two coordinate points. So, this graph aside, in fact, I'll probably just erase it. This graph aside, let's make up a couple coordinate points. How about 2, 5, remember that's my x, that's my y, and 3, 7. Let's start off easy. I have got a wonderful, wonderful little formula which talks about, which is called the slope formula. The way that looks is this. y2 minus y1 over x2 minus x1. Mr. McDougal, I'm confused. I'm used to those little numbers being above and being called exponents. Hold your horses. Those are called subscripts. They're just a label. This tells me I'm using my second y and subtracting my first y value from that. And I'm subtracting my first x value from my second x value. Now, I'll tell you this hint. It doesn't matter which coordinate point you assign as x as your first and your last. I personally just like to go with, something like that. Assign a point to it. So, with my formula, I have my x1 value, my y1. This just says it's my first x and it's my first y. Now I have my second x value and my second y value. Let's figure out what the constant ratio between these two coordinates is. So, let's plug in some values. And I'm going to do this with you first, then I'll backtrack away from it because I actually noticed this helped my students when I was teaching it earlier today. I'm just going to take this formula and plug it in. So y2 minus y1 over x2 minus x1. I'm going to look directly up at the values that I have here. My y2 is 7. My y1 is 5. x2 is 3. x1 is 2. Now we're just left with some easy subtraction and division. 7 minus 5 is 2. 3 minus 2 is 1. If I simplify that, I get good old 2. Now, I'll show you why it doesn't matter what order we go in. This has to do with proportionality. Let's just try flipping this around. So I'll make a little Bizarro World action here. I'll make this coordinate my second value, this coordinate my first value. So, y1, I should have thought up beforehand. Let's get a new pen. y1 minus y2 over x1 minus x2. I end up with negative 2 over negative 1, and that ratio simplifies to just a positive 2. As long as you are going in order from this coordinate to this coordinate or vice versa, it doesn't matter which one you choose. And since I have a little bit of extra time, let's make up another one to show you some other things that can happen. So let's come up with some new values. How about negative 2, 3, and 3, 5. Using my slope formula. And until I get into practice with this, I'm just going to assign some values here, because this helps me. This gives me a little bit of some mental practice, mental training. I'm also a coach. Practice makes perfect, all that good stuff. x1, y1, x2, y2. Plug in my values. 5 minus 3 over 3 minus negative 2. Let's see what happens. 5 minus 3 is 2. 3 minus 2 is 5. And I'm left with 2/5. Alright, that's another positive slope. Not too shabby, not too shabby. Let's do one just a tiny bit harder. How about 5, 6, and 1, 6. Using my y values. 6 minus 6 over my x values. 1 minus 5. Again, remember, starting with my second coordinate, moving to my first coordinate. 6 minus 6 is 0. 1 minus 5 is negative 4. And as we all know, 0 divided by negative 4 is 0. This is called zero slope, or no slope. If we understand positive and negative, it looks something like positive and negative slope. It looks something like this. Here's positive slope. Here's negative slope. Your zero slope is just going to be a pretty little flat line. You're not going anywhere. You set you on some skis, put you on a skateboard. If you're just flat, we're not moving anywhere. And the last thing that I have to show you is just undefined slope, which would give you a denominator of 0. Look something along the lines of this before I run out of time here. Say if you had 5 over 0, that's an undefined slope. That is a lesson for another day. But division by 0 takes mathematics and just chucks all the rules everywhere. So we'll just call this undefined. And that's all I have for you today. Have a good day.